Okay, welcome to Amuya Pro Science Tutor. My name is Comrade Stephen Cornelius Ngombianga. By the grace of God, I shall be taking you on the following courses. We have chemistry, biology, physics, and agri-science for science students, and biochemistry, microbiology for medical related courses, and what we call the public medicine or public health by the grace of God. So what you're going to do for us, please can you quickly go to the subscription side, click on the subscription box, then like our videos. Then you can go to the comment side for any complaint, any questions you want us to help. And also, if there's anything you want us to do to improve these classes, we are going to appreciate it. So please, that's the first instruction. Thank you. In chemistry, for WAEC level, we are going to look at the three basic branches of chemistry, where the questions, or let me say 80 to 90% of the questions of WAEC normally came from. So we're going to look at those branches and also talk about those topics in details. So the number one aspect of chemistry that we are going to be looking at is what you call the organic chemistry. Organic chemistry is another aspect of the chemistry in which we are going to look at in details. So here we're going to see what is an organic chemistry, then we'll look at homologous series, their reaction, their synthesis, very important. Here also we'll look at what we call the nomenclature. How do you name organic compounds? Most of the times, people do complain to us that this aspect of chemistry is a kind of difficult to understand, difficult to solve. They are kind of confused. What type of chemistry is that? But I bet you that organic chemistry is one of the simplest aspects of chemistry. And what you need to do here is just to follow the instructions given to you. So please, I'm going to talk about this in the details. So that's why you need to go to that subscription site, subscribe, like our video for more updates. So the second aspect of chemistry in which we're going to look at is called the inorganic chemistry. Inorganic chemistry. Then we also look at the this inorganic chemistry, we're going to look at the properties, the periodic table in details, the properties and characteristics of elements in the periodic table. So this is where we're going to focus on there. Then here we'll also look at your volumetry and volumetry analysis, which is subdivided into two, where you have we have qualitative and quantitative analysis. So very, very important. So we're going to talk about this in details before we get to nuclear chemistry, and just to touch some few other aspects of the chemistry. for WAEC students, for JAM, for NECO, for NAPTET, and any types of exams, we do prepare students for it. So please still go, and if you have not subscribed yet, please do that as I'm going to the main business of today. So today, let's start with the organic chemistry. Let's see what is an organic chemistry. What is what an organic chemistry? What do you understand by the word organic chemistry? What do you understand by the word organic chemistry? That's what we want to focus today. Now, I will try to be as simple as possible. Let me see how I can simplify this to your knowledge or understanding. So I believe you can see here. So what do you understand by the word organic chemistry? Now, we can refer to organic chemistry as the chemistry of carbon, as the chemistry of all the compounds of carbon. Are you following? The chemistry of carbon, or the chemistry of all the compounds of carbon. Now, if you say that, now focusing on their reaction, their properties, their synthesis, full stop. Organic chemistry, you can write as I dictate. Organic chemistry is the chemistry of all the compounds of carbon, of all the compounds of carbon, focusing on their reaction, on their properties and synthesis, full stop. But it's important for you to know that certain compounds of carbon are not included from this definition. I say what? Certain compounds of carbon are not included from this definition. That is, they are excluded from definition. And such compounds are the metallic carbide are not included in this definition of organic chemistry. Cyano salts are not also involved or included in this definition of organic chemistry. We can also, the oxides also are not included on this definition of organic chemistry. Then triazocarbonate 4 is also not what? Included from this definition of organic chemistry. And what are the reasons? The reasons are simple, and they are simple, and we can have as much as reason to not include these compounds in the definition of organic chemistry. The first reason, I might say here, is to make teaching simple. So imagine all those compounds are included. So to simplify teaching of this organic chemistry, so we exclude them from the definition. Then second but not the least, second here is to make distinction between an organic chemistry and inorganic chemistry. Please hope we are writing and we are following. Is to what? To make distinction between what? An organic chemistry and inorganic chemistry. Now, let me stop here. If I mention one, maybe let me say from creation or understanding the concept of this organic chemistry, it is known that is the chemistry of living things. Do you understand? The organic chemistry is the chemistry of living things. So those are the major reasons why these are not included in the definition of organic chemistry. And I would say it is important for us to know that the bodies of plants and animals are made up of these organic compounds. The bodies of plants and animals are made up of these organic compounds. And in the world today, we have numerous we have so many organic compounds found in the world today. And what is the reason? The reason is just few, which I want us to note. Number one reason why we have so many organic compounds in the world today is the ability of carbon to catenate. The ability of carbon to catenate. Let me write something small here at this junction. So we say catenate. Now, catenation or catenate means carbon bonded to carbon, bonded to carbon, bonded to carbon. So this kind of relationship, we call it what? Catenation. That is, carbon is bonded to carbon, and is bonded to carbon, is bonded to carbon, to bonded to carbon. So, and if carbon does this, it can either form a long chain. Now, this chain I can continue writing and continue writing as I'm moving. So carbon can do this to form a long chain, and it can also do this to form a branch chain, and it can also do this to form a cyclic chain. Can we just look at this illustration, for example? I can have a compound like this. This compound is called butane. This is called what? Butane. So don't worry, please. I'm going to teach you nomenclature, how to name these ones very well. But now let's understand the concept of this catenation. Now this is called butane, and I can write this in another form again. Do you understand? So did you copy? Okay. This is butane. So please look at the board very well. I can have another compound of carbon like this. Are we following? This is, can you see that? Carbon is bonded to carbon to form a branch chain. Do you see? So you call this one 2-methyl. You call this one 2-methyl propane. 2-methyl propane. 2-methyl propane. Very important. So can you see this? So this is what we call catenation. Can you see that? Still 4 carbon, but we are having what? Different what? Names. So I can have something like this also. Something of this nature. So I can call this one cyclobutane. So can you see carbon bonded to carbon, is bonded to carbon, and is bonded to carbon. So can you see that this one is having another different name? We call it what? Cyclobutane. Is in a ring form. Still, I'm going to what? Talk about this. So after understanding this, there are number 2 reasons why we have carbon, organic compound, numerous or so many, is the ability of carbon to bond with other compounds. In this structure, we can see that carbon has the ability to bond with hydrogen, right? Carbon with hydrogen. Carbon also has the ability to bond with oxygen. Or something of this nature. So carbon has the ability to bond with oxygen, with nitrogen and other compounds. So that also is the most reason why we have so many organic compounds in the world today. Please note this is very important. And carbon also has the ability to bond with either triple, single, or double bond. Something of this nature. Can you see? This is called what? Ethene. So I can also have carbon also bonded to another carbon to form triple bond. So I can call this one ethyne. Can you see? So carbon is bonded with triple bond to another carbon, single bond or double bond. So with these reasons, you can have what? That's why we have numerous organic compounds. Very important, note that. And there's something I want us to note. I want us to note something very important. These are called terms used in organic chemistry. What are the terms used? So for you to understand the concept of this organic chemistry very well, then it's important for you to know the terms that are used in organic chemistry. It's going to help you to understand so many things, most especially when we come to nomenclature. So the number one thing here we're going to be looking at is what is called, number one, is what is called homologous series. Homologous what? Series. Then number two, we're going to look at so can you see the terms? Can you see the terms used? Terms used in organic chemistry. So we say we have what? We have homologous what? Series. Homologous what? Series 1. Then number two here we have functional what? Groups. We have what? Functional groups. So in number 3 here, we'll look at what we call alkyl groups. So please, if you want to know how to name compounds, you must understand what homologous series are. You must understand functional groups and also be able to identify them, and also what you call the alkyl groups. You must get this very well, please. So we say the terms used in organic chemistry that we need to know are what? Homologous what? Series. We have what? Functional groups, and we have what? Alkyl groups. Please, I'm repeating and repeating for what? For your understanding, so that it can be as simple as anything for you. So please, and make sure you are following. Like I said, if you have any question, go to the comment section and let us know. So can we see what is a homologous series? So class, you can write. Can you write this as subheading? Homologous series. These are a group of organic compounds that follows a regular structural pattern. Homologous series are what? Group of organic compounds that follows what? A regular structural pattern in which each member of the series or successive members of the series differ with the molecular formula of CH2. It differs with the molecular formula of CH2. So each member of this series differs with this word molecular formula. So it's important you know that. So full stop. Are we all there? So we can have some characteristics of this homologous series. What are the characteristics of homologous series? So compounds of the same homologous series have one, the same method of preparation. They have the same word, method of preparation. So compounds of this same homologous series have the same method of preparation. We can also say that's the characteristics. Hope you're writing. They have the same general molecular formula. They have the same general molecular formula. So please note that. Number 3, we can say that each member of the series differ with the molecular formula of CH2. As I said earlier, each member of the series differ with the molecular formula of what? CH2. Very, very, very important. And number 4 here, they have the same chemical properties. They have what? The same chemical properties. But there's variation when we go down the group. They have the same word, chemical properties. So last but not the least here, they have different physical properties. They have what? Different physical properties. Very, very important. You know that. Okay, let me show you an example of homologous series. We have alkane, for example. Alkanes. These alkanes you're seeing, any member from this series has the general molecular formula CnH2n plus 2. CnH2n plus 2. That's their general molecular formula. So now, the first member of the series being methane is something of this. It looks like this. You call this guy what? Methane. So, second members of the series, you can have this guy. So you call this one ethane. So as you move down, you have propane. You are moving, you are seeing what? Butane, pentane, hexane, and so on and so forth. So as you move down the group, you have their physical characters changes because the numbers of carbon atom and hydrogen keeps increasing as we move down the group. So very important. So by now, I believe you should be able to give me the characteristics of homologous series, or you defined or tell us what you mean by homologous series. Very important. So the second here we say is what? Is alkyl groups. Is that the second one? Alkyl groups. Oh, you said alkyl groups, right? No, okay, functional groups. Okay, so let's take the functional group first. Functional groups. But alkyl is also part. But let's just go by what is inside your note. Functional groups. Functional groups. Are we all there? Functional groups. So let's try to define or understand what functional groups are. A functional group is something that is common. Do you understand? How would I put it? Let me try to be as simple as anything. Okay, for those of you that are writing JAMB, for example, let's use this example. JAMB is your functional group. Do you understand? If I say all JAMB students should come to my left-hand side, you understand? All of you will assemble here. WAEC, come here. So do you understand? Is that JAMB that makes you to come together? Are you getting? Or that particular WAEC is WAEC that makes you guys to look like brethren, like something brought you together, and it's called what? WAEC. Something brought you together, and it's called what? Functional group. Sorry, it's called JAMB. So that is your functional group. So listen, try to get my definition now. We say a functional group is atom or a bond. Is an atom or a bond that is common to a homologous word series. A functional group is a bond or an atom that is common to what? A homologous series. So let me show you something. I think this table is going to help you a lot. Let's see this table. Let's see this table. Let's see this table. Okay. Homologous series. Then functional groups. So let's just see some examples there. We say a functional group is a bond that is common to what? To a homologous series. So number one here, let us list some homologous series and see what is common between them. So we can have alkanes here. Alkanes. Then number two, we have alkenes. Then number three, we have alkynes. Then we can have what you call alkanos. Then we have alkanoid. All these are what? Homologous series. Alkane is a homologous series. Alkenes are what? Homologous series. Alkynes are homologous series. Alkanos are homologous series, and alkanoid are another homologous series. Number 6, you can have alkanoids. 7, we can have alkanos. Okay, let me stop here. At the course of our study, we shall look at all the possible homologous series. But when we say homologous series, this is what you need to understand or to note. So alkane to alkanos in this very table are examples of homologous series. So now, what is their functional group? Or what is common between all members of alkanes? Do you understand? That is their functional group. What is common between all the compounds of this homologous series? And what is common between alkanos is what is called what? Their functional group. So that's are the things we want to check. Now this guy, alkane here, we have single bond representing its functional group. This one, double bond representing its functional group. This alkyne is a triple bond representing their functional group. Alkanol, we have OH representing its functional group. Alkanoid, we can have COOH or C like this, representing its what? Functional group. Then for alkanoids, we can have COO like this, or we can have something of this nature, CO, representing the functional group. Then alkanones, we can have something of this nature, representing its functional group. So any homologous series, any organic compound that is carrying COOH or is carrying OH. If it's carrying OH, we say it's from the homologous series, alkanones. If it's carrying COOH, we say it's from alkanoid. If it's carrying double bond, we say it's from alkenes. It's from alkenes. So now, there's another thing very important you need to know about functional groups. The functional group determines the chemical property of that homologous series. You understand? So the functional group determines what the chemical properties of that compound. Very, very important. And another very important thing we need to know here, the functional group carries the parent name. It carries what? The parent name. So please, can you go through this table very well? Go through this table. Try to understand the functional group. Because I'm going to write some compounds and ask us to identify the homologous series in which they belong. So can we go through it? Alkane is single bond, alkene is double bond, alkyne is triple bond, alkanols, OH, alkanoid, COOH, alkanoids, COO. Then alkanones is what? CO. See, please, can you go through this? Go through it. So let me clean this and ask you to what? To identify some homologous series. To identify what? The homologous series these compounds belong. Okay, look at these structures. This is A, this is B. So now, based on the example I gave you, how do you know, or what is the name of this guy, or which homologous series does this A belong? If you look very well, and how do you identify the homologous series? What will enable you to identify the homologous series is what is called their functional group. So now, if you look at A, it has triple bond, right? So it's telling you that this compound is from the homologous series, what? Alkyne. Alkynes, because an alkyne has what? Triple bond. So if you look at this one very well, it will tell you that this very compound is from the homologous series, what? Alkanoid. So you call this first one ethyne. Then you call this one what? This is 3-methyl. This is 3-methyl. What? How many carbon? 1, 2, 3, 4. Butanoid. Butanoid what? Acid. So this is 3-methyl butanoic acid. So this functional group tells you that this compound is from the homologous series what? Alkanoid. And as you are naming, it must carry the name, the parent's name, which is Noi. This one must carry the parent name, what? Yin, alkynes, yans, alkynes. Do you understand? YNES. Very, very important. So I think this the little we can say for now about the functional groups. But if you keep following these classes, there are still more things you need to know about the functional groups. But we are trying to expose you to the basis of this chemistry, most especially this inorganic chemistry. So, but the last but not the least here is what is called an alkyl group. It's what is called what? An alkyl group. So let's see what is an alkyl group. Alkyl what? Alkyl group. So can you see an alkyl what? Group. So now, if you want to define an alkyl group, you need to consider their parent. The parent of alkyl is called what? Alkanes. So an alkyl is obtained or is gotten when an alkane loses its what? Hydrogen atom, or what we call proton. If an alkane loses one proton or hydrogen atom, we refer to it as what? An alkyl. Very important. Please, can you know that if an alkane loses its hydrogen atom, we call it what? An alkyl. The general molecular formula of alkane we say is what? CnH2n plus 2. CnH2n plus what? Plus 2. But alkyl is having the general molecular formula CnH2n plus 1. CnH2n plus 1. That is the general molecular formula of alkyls. So now, look at what I'm saying here. That alkanes minus one hydrogen atom is equals to what? Alkyl. So that's what I'm saying. So please, can you follow me and understand this? Because after here we're going to be talking about more important things. So look at the board, please. We say they are obtained from their parent alkane by the loss of one hydrogen. They are obtained from their parent alkane when the alkane loses what? A hydrogen atom, or what you call proton. Now look at the board. The first member of the series of alkane family is called what? Methane. Methane, and it's what? CH4. It's methane. Now, this is the first member of the series. If this methane lost one of its hydrogen atom, you don't call it methane again. This is from alkane, homologous series. Alkane. Do you get? So now, if you have this one, this is an alkyl. You don't call this one methane again because this one is having, can you see C? How many H? 1, 2, 3. This one is having C. How many H? 1, 2, 3, 4. So you are calling this one methane because it's having 4 hydrogen and 1 carbon. But this is having what? 3 hydrogens. So you cannot call this methane again. You call it what? Methyl. Methyl. So this is what? Methyl. You can call it methyl or methyl, whatever. But this is methyl, or you can call it what? Methyl. Because it's from alkyl. Alkyl, because an alkane lost its hydrogen atom. Let me take another example, maybe you understand better. This is 1, this is 2. If you have a compound like this, If you have a compound like this, can you see this one? This one is C2H6. This compound here is what? C2. Look at C, carbon. How many carbon? 1, 2. How many hydrogen? 1, 2, 3, 4, 5, 6. So this is called what? We call this one ethane. We call this one ethane. But now, when you come here, look at here. You have C2H how many? 1, 2, 3, 4, 5. So you have C2H5. So this can never be methane again. Sorry, ethane. This is ethane. This can never be ethane again, but we call it what? Ethyl. So this is what? This is ethyl because methane lost one of its hydrogen to become what? Ethyl. So an alkane loses one hydrogen to become what? An alkyl. Please, hope we are following. Secondly, alkyl are obtained from alkanes. Listen. Alkyls are obtained from alkanes when the ANE of alkane is represented by YL. By YL. So you have alkanes like this. Alkanes. Now, if you remove this ANE and put YL, then you have what? If you remove this ANE, you have what? Alkyl, and replace it to YL, you have what? Alkyl. Look at it. Alkanes, alkyl. So if you replace the ANE of alkanes with YL, what do we have? We have what? Alkyl. So very important. At the same note, can we look at the board? Look at this compound. I say methyl, I call methyl earlier on a structure, in a structure. So look at it. For example, you have this, then you have this. Don't worry, I'm going to teach you how to number organic compounds and name it. Most of the time, people ask, where do you number from? You number from left or right. Don't worry, we are coming to that. I think that should be our next topic. So I'm going to teach you which side do you number. The criteria of naming this, numbering of this organic compound. So you see this one, you can call this one, can you see that you're having CH3, C1, 2, 3, attached to this carbon. This is straight chain. At carbon number 2, you're having CH3 attached to it. So if you want to name this one, you call it what? 2-methyl or butane. Butane, very important. So can you note that? So I think the last but not the least here, what I want you to note before the next class. Most people ask us, how do you understand that this is propane, this is butane, this is pentane, hexane, heptane, nonane? How do you understand that this thing is that, is this? So please, can you go and study this? Study and practice, please. I'll give you an assignment today. So can you look at this structure? We say this is what? This is methane. Then when you have two carbons, you call it what? Ethane. When you have three carbons, call it what? Propane. So please go and learn this thing. From 4th carbon to the 10th carbon. Go and study this very well. So if you know that 1 carbon is methane, 2 carbon is butane, 3 carbon is propane, it's gonna help you to understand how to also name the organic compound. Because by the grace of God, if you get this concept very well, then we shall enter into what we call nomenclature of these organic compounds. Then we'll see how we can name compounds. You know, most of you are eager to start naming organic compounds. So once we get to nomenclature, you will name these things as if you are eating food. So please go back from the definition of organic chemistry, then through the terms used in organic chemistry. Those terms, I want you to pay more attention to the terms used in organic chemistry. So after doing that, once you get this very well, then lastly, try to know from 1st carbon to number 10th carbon. Let's stop there first. Try to know their names. Then it's going to help you a lot to understand nomenclature. You find it so easier. So please, like I said, if you have not subscribed yet, please go to the subscription box, click on that subscription, then like our video, and drop your questions on the comment section. If you have any advice for us, it's welcome. So I love you, and I love you very well. You just go home and study this for studying's sake. Thank you.